if a sign is hanging by two wires and they're even, then we can find the tension in each of these wires as long as we know the mass and the angle here. So we have two different wires and they are in tension. We also know that there's another mass down here, or that because of this mass there is a force of gravity. We're going to assume that the wires don't have any mass, which is not true, but it's negligible probably compared to the sign. So what you can do now is you could draw yourself a free body diagram. I'll just draw a small one right here. You have tension 2, you have, tension 1. Those are supposed to be at the same angle. And we have the force of gravity. Okay, I'm actually going to work from this up here just because I think with something that's got angles, this is a free body diagram, so it's pretty good. We know that the force of gravity is equal to the mass times 9.8. Okay, so that is 392 newtons, I believe, which means that the tension in wires 1 and wire 2 have to be 392 newtons to hold this thing up. But they're at angles. I mean, the y components of them have to be 392. Sorry, I misspoke. But they're at angles, so how can we find that amount out? Well, first thing I'm going to do is I'm going to look to the x direction to see what I can figure out about tension 1 and tension 2. You may suspect correctly that these have the same tension. But if we didn't know that for sure, if we want to prove that, we can sum up all the forces in the x direction, and what should they be equal to? Hopefully you would say 0, because it's not accelerating to the left and the right. That would be bad. So if I call the right direction positive, this tension has a component to the right of T2 sine of 30. Tension 1 has a x component of T1 sine of 30. So T2 sine 30 is positive, T1 sine 30 is negative. They should add up to 0. So T2 sine 30 has to equal T1 sine 30. If I move this T1 to the other side, you can divide by sine 30 and cancel both of those out. We figure out that T1 equals T2. So let's stop calling them that. Let's just call it T. Whatever the tension in one is equal to the tension in the other. And so now we can do the same thing, but we can look at the y direction. Okay, so this would be T cosine of 30, because if this is the angle, this side touches that angle, so it's cosine. And then this is also T cosine of 30. So there's 3 forces in the up and down direction. Sum of the forces in the y equal to, what are they equal to? Well, as long as this thing's not crashing to the ground, they're equal to 0. So we've got pointing up, T cosine 30 plus T cosine 30, minus, let's get rid of that, 392 equals 0. So I'm going to put these two together. That would make, I have 2t cosine of 30s, and they should be equal to 392. Basically, I can just do 2 cosine of 30, or divide by 2 cosine of 30, and I get the tension in each wire is equal to, come here, calculator, 392 divided by, notice I'm going to put this in parentheses, and that's so it will divide by both of those instead of multiplying by the cosine of 30. And I get 226 newtons. I really only have one significant digit, but I'm going to call it 230 newtons, but which is 2 significant digits. But the issue here, or what I want to point out here, is if you add that up, if there's 2 wires, that makes 460 newtons of tension. But because they're not both pointed directly up, they lose a little bit of their effectiveness, and so they have to be greater than 392 combined to make sure that this thing doesn't fall down. And that